Hello, welcome back. In this debugging practice, we will be analyzing the memory dump. So now, in this lecture, we're going to investigate the general signature in the kernel message. And in the later lecture, we will explore the signature inside the kernel message from RISC-V point of view. Later, we will discuss it more from Linux kernel perspective. So here is the screen that is the initial screen of Crash utility. As you know, debugging the Crash utility start with the log command. So I will use log command. So please look at this log command. After entering the log command, the kernel message is printed. So I will gather look at the more information. Here we go. And here is our signature at the moment of exception. So let me copy. So critical signature inside this, the kernel message. Okay. So let me copy. So at this point, so we will interpret the important signature in the kernel message. The first message you're going to analyze is this one. This signature tells us about the source path where this exception occurs. It also shows you the source file along with the line of the source code. It indicates that this exception occurs line 78 inside bug.c, the source file. Then another information, and you can see, is this one. The EPC that comes from the supervisor, exception important count registers. This signature indicates that this exception occurs inside this function. Then the RA register holds this information. That means this function calls this function. Then the information is the set of the general pop-up register from GP, TP, and T0, and so on. Another important signature is the value of several control status register. This is about supervisor status register. These values come from STVal register, and this is the value of supervisor cost register. The next signature we will look at is this one. This is the call stack. Let me copy this call stack. So once we review and investigate the signature from RISC-V point of view, next step is to analyze the call stack from Linux kernel perspective. So this call stack is split into two parts. The first part of the call stack is something that is executed from RISC-V point of view. So we can interpret that the right system call happens in the user mode. And another part of the call stack is about the generic API in the Linux kernel. As you can see, the call to this function is made, and then you can see the VFS write function. This API is the most used function when you access any type of the file, because it is one of the API in the virtual file system. And then after this, the execution flow, the call to lkdtmbug is made. Now we investigate the general signature from the kernel log. So we look at this signature from RISC-V point of view. Then we investigate this call stack from RISC-V point of view and Linux kernel point of view. Now we stop here, and then we'll continue the debugging in more detail in the next lecture.